Welcome, Archana. We'll be starting after 2 minutes. Okay, so let's start. I'll share my screen. Hope people will join in the middle. Uh, I hope my screen is visible. If it is not, please unmute yourself and tell me. Okay, so good evening, everyone. My name is Shutanu Sadhukan. I am a teaching assistant of NPTEL under PMRF. I am also a research scholar, PhD student at IIT Bombay. So I welcome you all to the fourth interactive weekly session of the NPTEL course code C39, right? The course title is Water and Wastewater Treatment. It is taken by the course instructor, Dr. Bhanu Prakash Belanki, who is an environmental engineer from IIT Roorkee at the Civil Engineering Department. So where are we? We are at the fourth week. So 3 weeks have been covered till now. And I hope everyone has given their feedbacks also for the problem solving sessions and also for the regular weekly course content. Hope everyone is able to access the recordings also. If any one of you is not able to access the recordings, in case you have missed earlier classes, please unmute yourself, and you can also type your any other queries or concern in the chat box. If you have gone through the previous sessions and you had any problem in understanding, then you can ask your doubt in the chat box. Okay, I hope everyone has given these feedbacks. If not, please provide your feedbacks. This will help us for gauging your expectation with which you registered under the course, so that we can modify our content accordingly if the course is not meeting your expectations, and obviously if it is justified. Okay, so let's start our today's session. So a little bit recap of the previous session. So in the second half of our last class, we discussed about different zones along the direction of a river, right? If the wastewater is introduced in a river in a particular point, then the river gets divided into four types of zones. And zone A, that is the previous portion from where the wastewater is introduced. So taking zone A, there are total 5 zones, and we discussed them according to their DO levels, that is the dissolved oxygen levels, and also number of total species, and also number of population of individual in species and number of total species. Based on that, we discussed all these things. Why there is a decline in the total number of species? Why is there is a increase in the population of individuals in each species? We discussed all those things. The number of species curve and the dissolved DO curves actually resembles. They are actually show similar pattern, but based on the pollutant, some specific types of species, actually their number gets increased. Actually, there are populations in those specific types of species which live based on the micropollutants that is present inside the wastewater. So there are specific types of species who eat those types of pollutants, and they increase in number, but the other types of species, their number gets decreased. That is the scenario here. Okay, so I hope everything was cleared up to this point. Then we, if it is not, then please ask question. Okay, so then we discussed on the biochemical oxygen demand, right? We understood the curves. The right hand side curve was mainly necessary for solving our problems, though one problem we didn't solve in our last class, that we will solve in our today's class. So this is basically your BOD curve, and LT equals to L0 into e to the minus KT. It is your DO curve. So BOD is nothing but the difference in DO at the initial level and at the final level, right? So LT, L0 minus LT, that is your L0 gets common from them, and it becomes 1 minus e to the power minus KT. It becomes your BOD at time t. Right, if it is 5 days, we also discussed from where the 5 days concept came into the picture. After that, we understood that BOD is basically the indirect measurement of the biodegradable pollutants that is present inside the water, biologically oxidizable micropollutants that is present inside the water. It is expressed actually by the difference of the DO levels at time 0 and at time t, that is after t days, let's say. Then we solved our first problem on BOD, right? I hope nobody had any problem in understanding this problem and the solution. I hope everybody understood that, right? If any step you have any doubt, then you can ask. This is the right time for you to ask. In this problem, it was simply mass balance, and there was no concept of that is called your the kinetics that we studied in that picture. It was not involved in this problem, right? I hope you understood this problem, right? Usha and Archana, probably you two are there in the last class, I think. And Borun, did you study this problem? I mean, did you saw the recording? If not, this is the time for you to ask. Otherwise, I'll this up to this point, it was discussed in our earlier class. Also, many other things were discussed, but I am not going to them because today we will be mostly solving problems with BOD. Okay. So that's why the concept, understanding the concept of BOD is important. Okay. So now comes our today's problem, first problem of today. Okay, so it is given as wastewater sample volume is given as 4 milliliter. The dilution water is given as its volume is 296 ml. Initial dissolved oxygen is 7 point. Initial dissolved oxygen means that is L0, 7.65 milligram per liter. The final DO after 5 days, that is L5 at 20 degrees centigrade, is given as 4.2 milligram per liter, and the kinetics constant, that is K, is given as 0.23 per day. Assumption is no organic content is present in the dilution water. Now the statement is, first you have to find out the BOD5 in milligram per liter of the wastewater. I hope you know the formula of the BOD5. We just showed that in the picture. Please calculate and type your answer in the chat box. I will give you 5 minutes. Kindly go ahead with your copies and note. I mean, taking notes is not necessary, but calculation, for calculation purpose, it is necessary. Please calculate based on the formula that we just showed in the picture. BOD formula is based on first order kinetics. So that's why we are getting the curves. They are asymptotic in nature. If you don't understand integration, differentiation, these things, if you didn't have mathematics in your +2 level, then you just have to memorize the formula and you can use calculator for the calculation purpose. If these type of problems are given in the exam, then calculator will also be allowed. If these type of problems, if calculator is not allowed, then the problems those will be given, you will be able to solve them by your I mean without the help of calculator only. So you can just go ahead and calculate this. I will wait for 2 minutes more. Use the formula BOD T equals to L0 into 1 minus e to the power minus kt. That is L0 minus LT, because L0 into e to the power minus kt is the formula of LT, right? It is the difference. L is the denoted as the dissolved oxygen, and the difference between the two dissolved oxygen, that is at the 0 level and at the time t, the difference is basically your BOD T. Here T is 5 days. K value is given. So just go ahead and calculate. Okay. So Borun has calculated as 253 milligram per liter. Archana and Usha also please calculate. I'll wait for 1 more minute. Before going to the solution, please, I think Borun got the correct. I forgot the answer. Okay, we'll see. This problem is based on kinetics. Previous problem was simple mass balance. So to answer that problem, the concept of integration differentiation, those are not required. And for solving this problem, you either you have to either conceptually you have to know, or you have to memorize the formula. That's all. Okay, I will now go with the solution. So by applying mass balance for BOD5, we can arrive at the following equation as I told earlier. So BOD is the DO at the zero time, that is initial, minus DO at final, divided by, here a new concept is there, that is called as the dilution factor. Okay. So I'll tell what is this actually. So equals to the DO as initial is given as 7.65. It is given in the question. You can see the initial DO is 7.65. The final DO is 4.2. So you have to take their difference. Now there is a dilution water. Okay, what is it basically? Can anyone tell? Any one of you? So based on the dilution water, actually dilution factor is being calculated. So we understood the concept of peak factor in the last class, which is basically a ratio. The dilution water is also a ratio. Why you have to divide the difference with the dilution factor? Can anyone tell? So what is this dilution water basically? It is okay. Usha and Archana has left. Okay, so for the recording sake, I will tell. So while testing a BOD, it is done that directly this 4 ml water is not used. So one water which consists basically zero BOD is used. It is actually mixed with the wastewater sample. So total volume becomes 300, right? But DO that we are getting, the difference that we are getting, it is based on the total, right? But we have to calculate the DO in the 4 ml. So that's why the dilution factor is 4 divided by 300. So unit of this is milligram per liter, 300 is liter. So we multiply this with this to get the milligram value and then divide it again with 4 ml sample to get that value in 4 ml. In this way, it became 258.75 milligram per liter, approximately 260. What was your answer? Yes, it is around that only. So I think instead of 300, you took 296, right? So that's why your value came a bit less. 253 is okay, but the thing is that instead of 296, you have to take the 296 plus 4. This is the total volume of the water with which you have to multiply this. Then you have to divide it with 4. 4 is the sample, actual sample, and it is the sample volume after addition of the dilution water. This is called as the dilution factor. So I think you took 296, right? Bodun.
Sir, I calculated in my mind that file. That's why.
Okay. So okay, so now we will go to our next problem statement. You have to estimate the ultimate BOD of the wastewater. Ultimate BOD you have to calculate this. So where this K value, it will be utilized, I think. Just I'll give you 2 minutes to calculate. So actually there are 3 TAs who are taking these problem solving sessions, including me. So you don't have to attend all the sessions. Any one among the 3 you can attend, or you can watch recordings. So the content those are delivered, those are almost more or less same. You can attend any one session you like, or you can alternatively just check. It is up to you. And these sessions will help you for your solving assignments, for your understanding, and also if you have registered for the final exam, it will also help there. So kindly calculate the second one using the formula that I told earlier. using the kinetics, that actually the K value will come into the picture. So I'll wait for 2 more minutes. Archana, you also try to calculate. So you have to calculate the BOD 5. Just apply the formula of BOD T, where T equals to 5. Just a first order kinetics formula. So the 5-day BOD you have to calculate. It is given by the following equation. Okay, the equation, if you remember, you just calculate it accordingly. Right. Okay, just use this equation. So L0 is your initial dissolved oxygen. K value is given. T value take it as 5. If K is in per day, then take T as 5 day. If K is in per second, then you have to convert the 5 day into second, like that way. So depending on this K's unit, you have to take T's unit, so that the entire term becomes unitless. Okay, just calculate and give me the answer. If you have noted down the problem, I think. So K is given per day basis, so it will be 0.23 into 5 day, right? And L0 is given as 7.65, right? Yes. So this will be the, sorry, L0, you have to, no, BOD T is this one, time. Yes, after T days, this is the your BOD. That is given. So L0 is being asked. That is the initial BOD or initial dissolved oxygen or whatever. Yes, so initial uh, initial dissolved oxygen is the ultimate BOD of the wastewater. Because if you see this graph, you will understand that BOD never goes zero. So if this is L0 at time t equals to 0, it never goes zero. So that's why the value of whatever L0 is there, if you put t equals to 0 here, right? So then BOD at 0 becomes L0. There is no degradation. In this case also LT becomes L0. So that is your ultimate BOD only. But even if you stay for infinity, as it is asymptotic decrease in nature, so even up to infinity, it will not become 0. So this is the only way to calculate the ultimate BOD. So whatever L0 value will get, that will give you the ultimate BOD. If you have understood this graph, you will understand this problem. Okay. So just put the values of the K values, T values in the formula, and you just get the value of L0, which is basically nothing but your ultimate BOD. It is approximately 380 milligram per liter. I hope it is clear.
Yes, sir, it's clear.
Okay. So now let's move on to the next problem. So the aeration tank, it is also a BOD based problem. The aeration tank in a wastewater treatment plant contains ml/VSS concentration of 3000 milligram per liter. So there are many concepts such as suspended solids, SS, MLSS, that is mixed liquor suspended solids, and MLVSS, that is mixed liquor volatile suspended solids. So suspended solids can be anything. I told you in 2 class back that what is the range of the particle size of for suspended particles. It is around micron level. So it's around 10 to the minus 5 to 10 to the minus 7 meter. So it can be organic, it can be inorganic. If it is organic, that is biomass, then it is called as mixed liquor suspended solid or MLSS. If the 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 organic content is activated, that is it is biomass, right? It can it can degrade the BOD content that is present inside the water, and it can increase in volume. That is, it can use the micropollutants that is present inside the water as its food, and it can multiply, right? So then the V comes into the picture. The MLSS becomes MLVSS. That is called mixed liquor volatile suspended solids. So this is the concept of SS, MLSS, and MLVSS. So in our problem, the concentration of MLVSS is 3000 milligram per liter. The plant receives a primary effluent with a BOD of 208 milligram per liter and flow rate of, that is the value of Q is 12 megaliters per day or million liters per day. Now the aeration tank has a volume of 1875 meter cube. You have to calculate the daily F by M ratio. What is F by M ratio? Anyone?
Food by microorganisms.
Yes. So food by microorganism. Yes. Right. So food is given as the BOD. So it is S, right? S or whichever value, whichever sign you take for that, and M is your X. M is given as X. So you have to just take a mass balance and calculate the F by M ratio. There will be a term called as per day. The time term will not go away, so that's why it is there. So please calculate. I'll wait for a minute. Both calculate. Archana also. If you Archana, if you are understanding, then it's okay. If you are not understanding, you should ask questions. That how it is being solved. Also the previous problems. Because it will help also other people who will be attending the session later. It is not a competitive kind of thing, right? NPTEL is for learning only. If you are attending one competitive exam course or something, then there may be something that I know something, I will not ask that question. It will give me a competitive advantage or something. But here we are not like that way. Here we all are for learning. So even if you understand, you don't understand, you have got a question in your mind, please ask. There is no ranking something kind of thing on there. There is no uh, kind of employment after this or nothing like that. So you can just increase your knowledge through the NPTEL course. Okay, so I'll go with the solution. So the data given, flow rate is given as 12 ml per day, that is 12,000 kiloliter per day. BOD in is denoted as S naught, which is equals to 208 milligram per liter, which is nothing but 208 same value gram per kiloliter. So milligram per liter means gram per kiloliter, same. Now tank volume V is given as 1875 cubic meters. Cubic meters mean kiloliters. Same. 1 cubic meter means 1000 liters or 1 kiloliter. So you can see we have converted all the three values into the same units, right? So MLVSS, that is mixed liquor volatile suspended solids, it is nothing but your microorganisms. Their concentration is denoted as X, which is 3000 milligram per liter. That means again gram per kiloliter, 3000 gram per kiloliter. So all the units are in same, they are same in units, and per day this term will be there. So the solution is, has anyone calculated? No. Okay. So daily ratio, that means per day term will be there. So that's why food divided by microorganisms. Food means what? This is the flow rate. This is the feed flow rate that is coming into the wastewater treatment plant. And S0 is the in milligram per liter unit or gram per kiloliter unit, it is the micropollutants that is present inside the flow rate. So microorganisms will be eating this as their food, right? So if you multiply those two terms, it becomes gram per day. This is the food inside the through the feed or via the feed Q into S naught. And MLVSS is not coming in, right? So microorganisms, we are assuming that they are not coming through the feed water. They are already present inside the tank. So it will be simply gram per kiloliter into kiloliter, the volume of the tank into the concentration of the concentration, that means mass per volume of MLVSS that is present inside the tank. So I hope you this is the total microorganism that is present inside the tank, and their ratio gives you food divided by microorganism ratio. I hope the formula is clear to everyone. It is simple mass balance. Okay. So per day it becomes, their value becomes, so Q is 12,000, S naught is 208, and V into X is this one into this one. Okay, if you calculate this one, I hope you will be getting the ratio as 0.444 per day. 0.44 into 37 something we got. So this many value per day. This is your gram per day, and if you multiply these two, it becomes gram. So gram per day is the unit of the food, and gram is the unit of the microorganisms. If you take the ratio, it becomes per day. That's why ratio per day is this one. So I hope it is clear. I'll move on to. So if you have doubt, you ask questions, please. Okay. So we'll move to our next question. So it is also a problem. It is also a BOD based problem. So all the problems we are solving are the concept of BOD is important here. Okay. So BOD is nothing but your dissolved oxygen. But when we take the difference between two dissolved oxygen, then it indirectly indicates to the amount of biodegradable or biologically degradable micropollutants that is present in the water. So that's why BOD is expressed as S0, substrate. And microorganisms will be eating that substrate and they will be growing in numbers. They will multiply, right? Biomass will increase. Okay. So now you have to consider, in this problem, you have to consider a completely mixed activated sludge process with Q. Flow is 4.5 million liters per day. Influent BOD is given. Aeration tank HRT, that is hydraulic retention time, is 3 hours. Biomass concentration in the tank is given as 2500 milligram per liter. It is your X, I think, right? Then quantity of waste sludge is given as 0.05 megaliters per day or million liters per day. Why? It is yield is given as 0.5. What is yield? Anyone? And KD is given as 0.05 per day. This is a bit complicated problem actually. So now average time, that is theta c, for which biomass cells stays in the system is 3 days. So why theta c? C is for cell. Theta is your HRT. It is 3 hours, and the theta c, that is cell retention time. C. Actually we in 2 or 3 class back, 2 class back actually we actually told the difference between theta, that is your hydraulic retention time, and theta c, that is cell retention time, or in some cases it is solid retention time or sludge retention time. Then it is given as theta s. So we actually told that in that problem there was no difference, but in this problem you can clearly see the difference. So it is 3 hours and it is 3 days. You have to convert it into same unit. Then the problem statement is, assuming that the authorities enforce a treated wastewater standard of BOD 5 equals to 20 milligram per liter, that is, you have to decrease the BOD from 210 milligram per liter to 20 milligram per liter. This is the difference, 210 to 20. And SS, suspended solids content of 20 milligram per liter. Then you have to calculate the MLSS concentration required in the system. The unit is milligram per liter. Okay, so only one question is given. You have to calculate the MLSS concentration required. So it is a bit tough problem. Please try to solve. I'll wait for a minute. Do you know the form? I mean, have you watched the SATs lectures? Have you watched the regular course content? If you have watched, you will be able to solve. If you have not watched, then also it's okay. I will be explaining. So here also you have to do a mass balance, right? I'll give you a hint. So you can see, as I told you, this is the influent BOD, right? 210 milligram per liter. This is the BOD. You have to bring down the BOD up to this level. So the difference, that is 210 minus 20. This many milligram per liters is the, what is it? This difference is the amount of BOD that will be eaten by the microbes. So the increase in their concentration will depend on their difference. And what is yield, as I told? That means the it is basically the biomass that is getting generated divided by the this difference. So whatever they will be eating, 50% of them will multiply. That means whatever amount they will eat, their increase in their mass will be 50% of that. So zero point 0.5 into this difference into the ratio of these two times, because the BOD that is coming in and that is going out, the flow rate that is associated with this is at this time scale. This is your 3 hours. But the rate at which they will be growing, that is your microbes will be growing, or say their cells will be multiplying, it is at this time scale, that is 3 days. So you have to take the ratio. So first you have to, either you have to convert 3 days into hours and then take the ratio, or you convert 3 hours into days, then you have to take the ratio between theta and theta c, and then with that ratio you have to multiply this difference, 210 minus 20 into y, that is your yield. One side of the equation this will be there, and the other side of equation two terms will be there. One will be the microbes, that is the concentration that is presently being generated, plus the concentration of microbes, they are decaying or dying. So that's why KD is there. So this term will be so whatever they are eating. So the number of decrease, the amount with which the food is decreasing, that is your BOD is decreasing, is equals to the number of increase in microbial biomass plus the dead biomass or the decayed biomass, whatever. So this is basically your mass balance. Welcome, Anushka. Please try to solve this problem. It is a bit complicated problem. If you have watched SATS lecture, you will be able to calculate. Otherwise, I'll also be solving this. So I hope the important data, those are there. You have written all of them. So Q value, theta C value, BOD S0, BOD 5, that is S5, yield value and KD value. All these values you have written, I think, right, to solve the problem till now. So that you will, when I'll be solving, you will be able to understand. Okay. Okay, Warren has calculated it as 8000 ml per liter. Ml per liter means unit is required milligram per liter. Okay, so I think we are talking about that only. We will see. I don't remember the formula. So these are actually gradually some deeper concepts are coming into the picture. These will be required while designing your activated search process for wastewater treatment. So there is a good book called Medcap. I don't remember the full name of the author. So the surname is Medcap, I think. So his book for designing wastewater treatment plants and also activated search process. They are very famous. Also nowadays, even nowadays also engineers use that book, formulas from that book for checking the design aspects. Although many membrane-based processes has come, those are most advanced, but still in India, most of the organizations are using the activated search process only in their plants. Okay, so we'll be going with the solution together. So useful data given is KD value is given as 0.05 per day. So one thing I will tell. So these suspended solids that is given here, it will be not it will not be required in our case. Why? Because suspend or the total amount of the suspended solids, they actually don't grow with time. Or only the my MLSS or MLVSS, this activated part only participates in decreasing the BOD and increasing their own number, right? See the other parts of the SS. So SS minus MLSS, whichever is left, that part actually don't contribute. That's why SS is not useful data here. So only the useful data given, those are like this way. So S0 is your initial BOD, theta is your HRT, and KD is 0.05 per day. S is your ST, that means S5. It is up to this level, you have to decrease the BOD from S0 minus S. Y is your yield that I told. So this many they are eating. 50% of them are getting converted into biomass, active biomass. And theta C, that is your cell retention time, is 3 days. So the solution is you have to do a mass balance, simple mass balance as I told you earlier. So mass balance is something like this. The MLSS concentration X equals to the yield Y into BODS, that is consumed. BOD is the consumed BOD you have to take. Consumed by whom? Consumed by this MLSS. Minus the MLSS deactivated or decayed or died, whatever. So balance is something like this. The X that you will have to calculate equals to the yield into the BOD consumed. So first BOD consumed is S0 minus S divided by theta. So it is your BOD consumed per this HRT time, and then you have to multiply it with theta C to bring it into the time scale of the microbial growth minus the MLSS gateway, or actually this was in the this side, so whatever consumed equals to whatever present plus whatever died. So the died one came to this side, so that's why the equations became like this way. Now formula used from the above mass balance is something like this. So x you have to take common, so it becomes within bracket 1 plus kd plus theta c. With that value you just have to divide this term, y into s0 minus s into theta c divided by theta whole divided by 1 plus kd into theta c. So this is your formula for getting the value of x, that is MLSS concentration in milligram per liter. Okay, I'll give you 1 minute more. Just put the values and calculate the data. Put the data and calculate the value. Okay. Um, okay. Archana and Anushka, and also Borun, check whether this formula only you have got, right. With this you have calculated. So there are other types of problems also. There are problems based on enzyme kinetics, monode kinetics. So whenever the yield will be given, the y whenever it will be given, you have to use this formula. If they have given a yield means what? You have to take the total difference in BOD and you have to just multiply it with the yield. That's all. So if the yield is not given, instead of some other kinetics, let's say monode kinetics is given, then you have to utilize that to calculate the biomass that is getting generated or currently present inside the tank. Okay. So then the x becomes, after putting all those values, yield is 50% divided by 1 plus kd into theta c. So kd is 0.05 into 3. It is your 3 days. So the 3 hours we have calculated in terms of day. 3 divided by 24 equals to 1 by 8. That means 0.125 day. So this is utilized for calculating this ratio theta c divided by theta. That means 3 divided by 0.125 whole into the difference, that is the food that is consumed, or BOD that is decreased. It is your 210 minus 20. So after calculation, it gives you X as 1982.6 milligram per liter. That is 1983. So if this calculation is correct, so Gordon, please check whether probably you have not considered the decay thing, right? So that's why you got a bigger value, I think. It is, I think, so 1.15. Or maybe you have considered the total BOD is 0. That's why. I also don't remember whether the value is. Well, let me calculate also. Ah, So it is your 210 minus 20. That means 190, right? 190 into 3 into 8. That means divided by point is this one. So 4560 divided by 2. That is into 0.05 into 1 point 3 that is 1.15, right? Okay, my value is not, maybe some problem is there, but however, so just calculation there may be something wrong, but I hope you get the idea. 3 So it is 190 only, yes. 1.15 with 1.15. Oh, sorry. With 1.15, you have to divide it. Divided by 1.15 squared, right? Yes. So yes, the answer is correct. 1983 milligram per liter. Yeah, yeah. So I hope it is clear. If any doubt, you can ask. Otherwise, we will move on to the next MCQ. So there is a picture that is given. This picture we saw at the starting of our today's class. So there was one picture. The right hand side there was the kinetics, and the left hand side there was this picture. So the questions that has been asked is something like this. The second stage BOD, as shown in the figure, this is the second stage. Okay, it is due to the experimental error, the nitrification demand, the increased activity of bacteria, and option D is interference by the certain chemical reactions. So please type your answer in the chat. Okay, it's okay. Yeah. So Borun, if you, it's okay. So first, I mean, this problem is not very easy. So if you have just, I mean, you have just to either you have to remember the formula or you have to derive the formula from mass balance. Nothing else. So if you have understood the concept, 50% marks it will be given, I think. So if it is an MCQ, you have to definitely give the correct answer. Nothing can else can be done about it. But if it is kind of written exam and mm, you have given, I mean, you have up to the derivation stage you have done correctly and you have put the values correctly, then I think partial marking will be given. So it depends on the type of the question. So it's okay. By practice, it will be all right. Okay, so everyone is telling B, so I think it is correct only. The answer is nitrification demand. So which is the reason of the second stage BOD as shown in the figure. What is the time now? 7:55. We'll with this actually the BOD concept comes to an end. The BOD and its associated problems. If you have any, I mean, BOD is a vast and complicated thing. So if anyone has any doubt regarding whatever was discussed till now, one can ask. Otherwise, we'll take a 10 minutes break and we'll join at 8:10 sharp, 8:05 sharp. After it is 7:55, so we'll join at 8:05. I will be here, so you can ask questions based on the BOD. Okay. You can ask. Otherwise, we will join at 8. We'll take a short bio break. We will join at 8:05. I am here. You can ask questions. No issues. Yes. If Yes, Archana, go ahead. Uh, what is your question? Are you there? Have you typed anything? Or just-
Question regarding second
Huh?
second assignment.
I don't understand. Please be louder.
Sir, I have a question from
Yes.
assignment second.
Assignment second.
Yes,
Okay.
sir.
Assignment second. I have to open them. Just wait. What is it? w.swayam.gov.in. Uh, courses. So current assignments you are talking about, right? Mhm. Week two assignment two. Solution is also provided for this, right?
Yes, sir.
So did you see any problem in the solution? What
No,
is the
sir, but I'm not getting it.
problem number?
Problem number 8.
3, 4, 5, 6, 7, 8. This one. Okay. So I have to see it. The floated through a reactor. Okay, let me share my screen also. Uh, or is it uh, sharing that screen? Hmm. Okay. I have not seen the problem, but let's see. What is your doubt? If I cannot answer in this class, I will come with the answer in the next class. So
Okay, sir.
yes, this is the problem, right? So
Yes,
you
sir.
are totally you are not getting the solution, or some part of the solution you are not getting.
Sir, I didn't get the part of the solution.
Uh,
In the solution,
yes,
so the formula is C equals to C naught by 1 plus KT.
yes,
Sir,
yes.
yes, sir. So the third point,
Third line,
zero
this
point
one.
0.8 equals to,
Yes.
sir,
So zero. Yes, tell me.
so there is written T CMFR equals to 0.25 by K.
Huh.
So, sir, how it comes?
Okay. So if you take this in this side. So it becomes what? 1 by 0.8. That means 1 by, sorry, 10 by 8, right? 10 by 8 means your 5 by 4. That means 1.25, right? 1.25 minus 1. That becomes your, because 1 plus kt comes into the left side. So in the right side, it becomes 1.25. It left hand side, it becomes 1 plus kt. That means kt equals to 1.25 minus 1. That means 0.25, right? That means T equals to 0.25 by K. Simple. TCMFR means continuous mixed flow reactor. Why is it so? It is the retention time inside the reactor, or space time it is called. So actually they have skipped from the second step to this third step. They have skipped several steps. So that's why
Yes.
it seems confusing. But you just solve them. You take this, you just invert this right hand side, you invert the left hand side, you will get 1.25 in the left hand side, 1 plus kt in the right hand side. You take this 1 into the left hand side, it will be 0.25. Then you divide it with k, it becomes t equals to this one. That's all. I mean, simple, nothing else. You just do it in your copy, you will be able to understand. They have just skipped these steps. This formula
Okay,
you are
sir.
able to understand, right? This we discussed
Oh,
in the last to last class.
yes.
Also in the recap in the last class. So this we discussed how they are getting this. This is probably based on the order, right? They must have mentioned the order of the reaction. Yes, first order kinetics. You see, they have mentioned. First order kinetics means C to the power 1. K into C to the power 1. This is the rate equation. Okay.
Okay,
So
sir.
if you solve that thing, then you will come in this formula. So this formula you are able to understand, right?
Yes, sir.
Only the calculation you had it out. So now is
Y-
it clear?
yes, sir.
Okay. Just they have skipped these steps, nothing else.
Okay, sir.
Hmm. Okay. So I'll be sharing my uh, screen. Right? Is it visible? Okay. So we will be doing our next problem. So BOD related problem is over. Now we will be solving some general MCQs. So which one of the following factors affects the efficacy of a coagulation based sedimentation in wastewater treatment? Option A, pH of the wastewater. Option B, temperature of the wastewater. Option C, surface overflow rate. And option D, all of the above. You type your answer in the chat box. Borun has left. Rovi has joined. Welcome, Rovi. Give the answer in the chat box. Arshana is telling all of the above. Oh, Borun has rejoined. Oh, no, not rejoined. It is the earlier answer. Okay. So I hope it is the correct answer only. It is all of the factors, that is pH of the wastewater, temperature of the wastewater, and surface water rate, all of them will be affecting the efficiency of a coagulation based sedimentation in wastewater treatment plant. Because pH means the concentration of H plus ion. Depending on the concentration of the H plus ion, the attachment of smaller particles to get bigger particles at their molecular or intermolecular level, they will be affecting. Temperature also will affect the coagulation based sedimentation. Sometimes temperature increases the intermolecular gap of the water, thereby increasing the suspension and delaying the sedimentation. Sometimes it becomes the cooled water also increases the rate of the sedimentation. Sometimes opposite happens. That's why temperature may affect, and surface water flow rate will also happen because there is some design aspects. So if the design is not done properly, the surface water flow rate is not uh, decided properly during the design, then it can also affect the coagulation based sedimentation. Okay. Next MCQ. Activated sludge is the resultant sludge removable from the aeration unit. Sludge settled in the humus tank. Sludge in the secondary tank. Post aeration, rich in microbes. And option D is sludge in the secondary tank. Pre aeration, rich in nutrients. Which one is the called actually your activated sludge? Rovi is telling option A. Resultant sludge removable from this answer you are giving as A or last answer, I think. Last answer he was giving. Okay, last answer was all of the above. Please give answer to this. What is the activated sludge is basically what? Okay. Probius left. Uh, we are talking about the sludge in the secondary and pre-aeration rich in nutrients. Why is it so? It should not be so. Let me explain. So the correct answer is rich in microbes. So you see, rich in nutrients means high BOD. High BOD means the feed water basically, nothing else. But after the aeration, the quantity of the aerobic bacteria that is present inside the sludge, they gets increased. That means that sludge now is ready for the treatment of the wastewater. That is your decrease of the BOD. The sludge is now ready. So that's why it is called as activated sludge. How you are activating the sludge? By the help of the aeration. So post aeration means after aeration. Pre aeration means before aeration. So after aeration, the microbe content, the active microbe content, who will participate in the decrease of the BOD, they actually increases in the sludge. Their amount increases in the sludge. In the sense, sludge becomes activated for the requirement for the treatment of the wastewater. So that's why the post aeration post aeration sludge, which is rich in microbes, that is rich in aerobic microbes specifically. So it is called as your activated sludge. The others are not activated. Sludge essentially numerous tanks means the sludge has done its job. So it is now low in micronutrients or high in dead micronutrients, you may say like that. Resultant sludge removal from the aeration unit. I mean, this sludge is to be removed. So it is not participating in the uh, your uh, removal of the BOD. And also the last one, it is basically nutrients means high BOD content. It has nothing to do with the microbes that is present inside the sludge. So activation means increase the microbes microbe amount inside the sludge. So activated means the third one only. So it is the correct answer. I hope it is clear. So now we'll move on to the next section. So in the monod equation, as I told, so in our earlier problem we have seen y yield was given in that equation. So now the question is regarding monod equation. It is an MCQ and the options are: in the monod equation, mu represents the substrate concentration at which specific growth rate is half of the maximum. Option B is the maximum growth rate of considered microorganisms. Option C is the concentration of the limiting substrate for growth, and option D is none of the above. So if you remember the monod equation, you will be able to answer the question. What is monod equation?
Sorry, sir, I don't know.
Okay. So monod equation is basically, I'll tell you. So hint is, this is the form of the monod equation. Mu equals to mu max into concentration of S, that is your substrate or BOD, divided by Ks plus S. These are all microbial kinetics. So microbes are eating the food, that is the BOD, and they are increasing in numbers. So there is a growth of microbes and there is a decrease of the decrease of the BOD level. That is the level of food or level of substrate or level of micronutrients that is present inside the water. You can see there is a decrease in their number and there is an increase in the microbe content, right? So this type of equations relates the growth of the one and the degradation of the other. So S is getting degraded and mu is getting increased. Mu just doesn't represent any one of them. So none of the above is the answer. Okay. So mu max is the maximum growth rate of considered microorganism, and mu is the growth rate of the considered microorganisms, not the maximum. Okay. S is the substrate concentration, concentration of the limiting substrate for growth, and Ks is the substrate concentration at which specific growth rate is half of the maximum. This is your Ks. Okay. So our earlier yield equation actually was given something like this. There mu equals to y into S naught minus S into theta, the ratio of the thetas. So it was given in the earlier problem. If mu, the monod equation, let's say in this problem, the problem we earlier saw for our BOD, what is it here? So if instead of yield, instead of giving the y value, if they told that the growth of the microbes simply follow the monod kinetics, and instead of kd, if they have given the value of ks here, then you have to use the monod equation that is given as this: mu equals to mu max into s divided by ks plus s. Here the s will be that difference, 210 minus 20 equals to 90, or some data will be given like that way accordingly. So instead of following the yield equation, it will simply for the monod kinetics like that way. So there are also other kinetic equations also. This is simple. These all of these kinds of equations, be it a yield, be it a monod equation, they actually relates the decrease in the BOD level and increase in the microbial content. Understood? Okay. So now our next MCQ is: the most commonly used adsorbent for water purification is option A groundnut husk carbon, option B activated carbon, option C coconut shell carbon, and option D is neem bark carbon. Welcome Horithra 17. Please answer the question and type in the chat box. Orchana is saying as option B, Horithra is saying as option C, and B option B you are saying. Activated carbon, I think both of you are correct only. We'll see. So the answer is activated carbon. Yes, you are right. So activated carbon is by far the most commonly used adsorbent and is particularly suited to the removal of apolar components. So water is polar or apolar? What do you think? You know about apolar, right? Okay. So is the activated carbon is the correct answer. Water is polar in nature, and if some compound that is dissolved in water and is apolar in nature, dissolved or suspended, whatever, so activated carbon will adsorb it. So you know the difference between adsorb and absorption, I hope. Absorption is a entire the material is used for absorption, absorbent, and absorbent. So the absorbing material, there are pores, and throughout all the pores actually it will basically absorb. But the adsorb is surface phenomenon, either in a multi-layer or is in a single layer at the surface level. So there are two types of adsorption. One is chemical adsorption and one is physical adsorption or physisorption. They follow separate kinds of thermodynamic equations, which are represented by by several isotherms like uh, Bamar Emmett Taylor isotherm or BET isotherm, or there are also other types of isotherms based on chemisorption or physisorption, whatever, multi-layer or single layer, and they are called as adsorption isotherm. Okay, now we will move on to our next MSQ. So it is a multiple select question. In select the incorrect statements regarding water quality. So there may be one or more statements incorrect regarding water quality. Option A is chlorides in potable water may be present from 300 ppm to 500 ppm. Option B is in order to be safe against pathogenic bacteria, residual chlorine should remain between 0.05 ppm and 0.2 ppm. Option C is presence of iron and manganese in excess of 0.3 ppm in drinking water is objectionable. And option D is pH value for pure water is nearly 7. Which one or two among these statements are incorrect with respect to water quality? Specifically, water that is used for drinking or household purposes. Which one do you think? Please type your answer in the chat box, both of you. One or more than one, because it is an MSQ, so more than one options may be correct, may be incorrect, as it has been asked. I'll wait for 2 minutes. Purita is saying as option C is incorrect. So there is no concept involved in this question. You just have to remember the data, that's all. Sometimes it is very unfortunate that there are certain values, they are very regarding, if you are a water scientist, so the market or the yes, the job market demands you that you should remember certain values from by your heart. They are very obvious kind of thing, just like pH value, as it is 7 means neutral, so this value you have to remember by heart. There is no concept, and there is concept obviously, but you are not going to derive it uh, from different factors like that. It is not so. So you have to just remember. This is also just a problem remembering the water qualities. Okay. So otherwise, in when you will be working somewhere, then you can always use the internet to check it. So no problem with that, but it is better to remember some things sometimes. But it's okay even if you don't remember, because concepts is more important. One or two problems maybe in the exam may be given which are memory based questions. Okay, so the answer is one. Though it is an MCQ, a MSQ, only one option is incorrect here. It may be so. So chlorides in potable water may be present from 300 ppm to 500 ppm. It is an incorrect statement. Okay, so it is less than that. It is not such higher tolerable limit. Okay, so the other options, which are B, C, and D, are okay with respect to water quality. Now, our next MCQ: sand and grit particles are usually removed from wastewater by which type of the following settlings? Option A, flocculent settling. Option B, discrete particle settling. Option C, hindered settling. And option D is compression settling. One option is correct among them with respect to grit and sand particles removal. Please, I'll wait for a minute. Please type your answer in the chat box. Welcome, Orchard. Oh, no, Orchard, you left. Okay, give your answer in the chat box. Horitra, actually, you didn't join the first half of our session, that is before 8 p.m. So we discussed some important problem based on the BOD concept. So in an exhaustive manner, almost all the problems has been discussed. So if you don't know, you can whenever the recording will be uploaded, you can watch, and you can also watch the last class recording. And again, if you have any question, you can come back in our next class, or you can upload your question in the forum of the main portal of regular course content. There is a tab named as Ask a Question. Okay, so this question you please answer. Archana is saying as option B, discrete particle settling. Paritra. So the flocculent settling, this is a coagulation kind of thing. Sand and grit particles are bigger particles, they don't coagulate in normal temperature, right? And in whatever temperature they fuse together, in that temperature water doesn't remain in liquid form. So this gets cancelled out. The compression settling, there is nothing. The use of compressed air is optional. Even if it is there, it is used for the flotation of oil and grease, right? It is not for the settling of the sand and grit particles. Hindered settling means you are using certain baffles or something. So they are also not. I mean, though baffles may be there, but their purpose is not the removal of sand, grit, and sand particles. So discrete particle settling will be the correct answer. Whatever both of you has given, it is correct, because you will see there is a formula I told you in the last class, that is called the terminal formula of the terminal settling velocity, right? And there is a concept of drag force. So if FD is the drag force, and V if it is the terminal settling velocity. Terminal settling velocity means what? The velocity at which the particles are getting settled inside the settling tank. Their velocity is not accelerating, not retarding. So if FD is the drag force that is offered upward direction on the particle by the water, then the relation between FD and V will be FD equals to 6 pi eta RV, or 3 pi eta dV, where R is the radius and D is the diameter of the particles, grit or sand particles, if we assume it to be uniform. Okay, and eta is nothing but mu, that is your uh, that is called as your viscosity of the water, and V is your terminal settling velocity. So 6 pi eta RV, this or 3 pi eta mu, 3 pi mu dV, this you have to remember, because this is very important concept for solving further problems. This is a problem. This is a thing for drag force. We'll be solving certain problems based on the balance of the drag force with buoyancy and gravity. If you balance the buoyancy plus drag force equals to gravitational force, that is your weight of the particle, like this way. So we will get certain equations. So based on those equations, we'll get certain formulas, and based on those formulas, we'll solve certain problems. So our next MCQ is the composition of TKN, that is total gel-dull nitrogen. K is silent. In domestic sewage is expressed in milligram per liter as nitrogen. Which of the following is the result of the addition of option A, nitrogen from both organic and inorganic sources in sewage? Option B, nitrogen from organic sources and nitrite in the sewage? Option C is nitrogen from organic sources and ammonia in the sewage, and option D is ammonia and nitrite in the sewage. So organic or inorganic, organic or nitrite, organic or ammonia, or ammonia or nitrite. Which one among the four is expressed with the help of the TKN, that is total gel-dull nitrogen, and expressed in milligram per liter? Please type your answer in the chat box. Only two of you are there. Oritra is saying option C. Archana. Okay. Okay, so answer is two, whichever you have given. Nitrogen from organic sources and ammonia, not the nitrite one and not the inorganic one. So these two only is represented by the TKN, total gel-dull nitrogen. Total gel-dull plus nitrogen from the inorganic and nitrite sources are expressed as the total nitrogen, Tn. Gel-dull means the organic and ammonia. Because there are basically nitrogen is abundant in the air, but there are specific methods with which the ammonia can be the soil can be nitrificated, right? Most of the organic sources, that is your plants and etc., the leguminosaceous plants, they take the nitrogen from the air and they insert the nitrogen in the soil. So all of these types of all the nitrogens are basically ammonia and organic nitrogen only. They are represented with the help of TKN, but the other inorganic and nitrite, they are separate. So they are mainly by chemical reactions, they are infused inside mineral rocks. The other are by biological reactions. Okay. Okay, I don't know. It's okay. Just you have to remember. Then our next MCQ is, which one of the following is not a step in the ASP? ASP is the short form of activated sludge process. Option A, mixing and aeration of the mixed liquor. Option B, settling of the mixed liquor to separate the sludge. Option C is anoxic conditions for denitrification. And option D is drying of the sludge. Which is not a step? Which one among the four is not a step of the activated sludge process? So all of the four, I see there are involvement of the sludge. Only in the third one, I see there is no sludge term is there, right? No, in the first term also, there is no sludge term. Let's see which one is the correct answer. So all of the processes are associated. Please type your answer in the chat box. All of the four processes are. Haritra is telling option D. Archana is telling us option D. Both of the processes are both of the all of the processes are basically related with activated sludge process, but here what has been asked, it is not a step of the ASP. That means what? ASP what is the target of ASP? It is to remove the BOD content, or it is to reduce the BOD content that is present in the water. So all of these steps, all of these steps which are correct, they should have certain contribution for the reduction of the BOD from the wastewater. Though they may, if they don't have such contribution, though they are associated with the activated sludge process, they will not be considered as a step. Okay, so I think both of you has given the correct answer. It is the drying of the sludge. Oh, sorry, another option was there. It was the flocculation of the mixed liquor. So you have given the correct answer only, because all of the other four options, that is mixing and aeration of the mixed liquor, flocculation of the mixed liquor, anoxic denitrification, and settling of the mixed liquor to separate the sludge, all of the four processes are along the direction of the flow of the wastewater from through that path, or through that path, the BOD of the wastewater from higher concentration to lower concentration is getting decreased. But the drying of the sludge is kind of offshoot in a separate process. You may or may not dry the sludge. It has no contribution. Whether you are drying the sludge or you are not drying the sludge, it has no contribution in the reduction of the BOD. So it is not again mixed in the mainstream. After drying of the sludge, it is basically thrown away, or it is used for the land filling purpose, or sludge cakes are used for let's say for making bricks, for making fertilizers. For these purposes actually this is used. It has no contribution for the reduction of the BOD, so that's why it is not a step. Both of you have answered it correctly. So now our next MSQ, that is your multiple select question. More than one options may or may not be correct. Wastewater has various kinds of nutrients present which can be used by microbes for cell synthesis. These nutrients is your BOD. यही बात है कि शुरू से इसी बारे में हम बात कर रहे हैं इसमें, right? So you have to select the following nutrients that is or are categorized as major nutrients. Option A is sulfur S, option B is phosphorus, that is P, option C is Ca or calcium, and option D is Na or sodium. And option E, that is also another option. It is nitrogen or N. Okay. So which one or two or three or all of them among them are the major nutrients that can be used by microbes for their cell synthesis? That you have to answer. B and E, Archana is saying B and E, phosphorus and nitrogen. Horitra is saying all of them. B, A, C, D. See, all of them are nutrients, right? But some of them are major nutrients. So that's what they are called. Have you heard about fertilizer, critical elements in fertilizers which are used for growth of the plant? So same nutrients. Here also the same nutrients. They are the major nutrients. Though all of them are nutrients. Basically, all of them take in certain extent they participate in the cell synthesis. But the major nutrients, they are in plants case for fertilizer scenario, they are called as NPK: nitrogen, phosphorus, and potassium. In our case, the potassium is not given, so that's why option B and E, that is your phosphorus and nitrogen, will be the correct answer. Okay. So whatever the plant scenario, in our microbial wastewater treatment also the same scenario holds. They are critical elements. They are the major elements. Though the other elements are also important. These two elements or three elements, potassium is not there. So these three elements are highly important for the synthesis of the cell. Okay. So now our next. So there is a problem. So the municipal corporation must handle a daily water volume of 720 meter cube. So you can see the influent is coming and influent is going out. This rate is constant so that there is no variation in the height. So this constant rate per day is given as 720 meter cube. Okay. So it was found that the overflow rate, that is overflow from above the well, it is 16.5 meter per day. It is basically your velocity. Depth of the tank is given as 3.5 meter. Width, that is, if you consider this as a settling tank, width will be in the perpendicular direction of the paper. Okay, so if h is the depth, this is the flow rate, and the problem is, based on the above data, you have to calculate the length, that is L, you have to calculate, of a rectangular settling tank designed for the removal of discrete suspended particles. So I'll give you a hint here. So this depth that you are saying, you are seeing, it may vary also in some cases. That's why I have taken this picture here. So if the depth varies, though the rectangular, it has been told, the rectangular settling tank and the depth, these things are told here. So will it be useful for your calculation purpose? So my hint is no, depth is not important. So now we calculate. Now the problem becomes very simple. Welcome Chandrakant. Go ahead with the problem. Just calculate the. Yes. So ask question. Chandrakant, go ahead. What question do you have? Hello, are you there? You are muted. I'm audible to you, right? Maybe he raised the hand by mistake. Okay, so you two please try to answer. Now the depth, the data is no, will not be required. Now the problem becomes very simple. Simple calculation. You have to calculate the length L uh, of the settling tank. Considering the volumetric flow rate of 720 meter cube per day, the overflow rate, that is velocity, 16.5 meter per day, and the width, that is 5 meter. It is perpendicular to the direction of your screen. It is not visible. So we will see the solution. Anyone of you two? I will give you 2 minutes. Okay, Horita don't know. Archana also, I think. Okay, we will solve the problem. No issues with that. So useful data that is given for the settling tank is something like this. Q or flow rate is given as 720 meter cube per day. B, that is width, is given as 5 meter, that is perpendicular to the direction of your screen. SOR, that is your overflow rate or velocity, it is given as 16.5 meter per day. So now you can see the width as a surface area, that is important for settling. Okay, surface area means what? The length of the tank into the width of the tank. The depth may vary, though it is mentioned rectangular here. It is basically means the top surface area is rectangular. So the depth may or may not vary, but it is not important from design point of view. So only the top surface area is important. So that's why the solution is something like this. The surface area equals to the volumetric flow rate divided by the velocity, that is your overflow rate. So it is meter cube per day divided by meter per day. The top surface area becomes meter square. So 720 divided by 16.5, it becomes 43.64 meter square. Okay, this is the trick here. So some people will confuse it with the depth. So the depth concept is not important in case of settling. Okay, so now you can calculate, I think. So the surface area, one formula is the Q divided by the overflow rate. That is the volumetric flow rate divided by the overflow that is occurring from up the weir, right? So it is one formula of the SA, and the other formula is the top surface area, that is your L into B, length into breadth or width, whatever, but not the depth. So L into B is your S. Now you equal this to L into B equals to Q by SOR. It has been calculated as 43.64. Now you have to calculate the length of the settling tank. So length becomes the surface area divided by the breadth, which is given as 5 meter, equals to 8.73 meter. 43.64 divided by 5 equals to 8.73 meter. It is the required length of the settling tank. So as the velocity, terminal settling velocity does not vary with the depth. So that's why from settling point of view, the depth is not important. But still depth is important. From what point of view can you say? So see, it depends on the amount of the or the concentration of the particles that is present inside the feed water. So if the concentration is high, the sludge hopper will be full in a short period of time. If just if your concentration of particles at the inlet feed water is low, then it will take time to open to fill up the sludge hopper, or sorry, sludge blanket. Right, so sludge blanket will be there on this sludge hopper. It will take time. Sorry, it will take less time if the concentration is low. So if the concentration is varying, then also then the time for filling the sludge hopper will also vary. So there will be a frequency that with which you will be opening the valve that is present at the bottom of the sludge hopper to take out the sludge that is deposited or the particles that is deposited at the bottom of the settling tank, right? So based on your frequency, based on the inlet concentration, you actually design the depth. So if it is very fluctuating, then you take the peak concentration, you take the lowest concentration, you take an average for the design purpose, like that way. So from that point of view, from what will be the frequency of your taking the deposited solid out of the tank. So from that point of view, depth is important. But from design point of view, your main motive here is to settle the large particles. So from that point of view, the depth is not important. The surface area is important, because you change the surface area, you change the length, you change the breadth. What will happen? The overflow rate will change, right? If the overflow rate changes for the same Q, the settling also gets changed. This is the main design parameter here. But velocity, terminal settling velocity does not depend. This is not the terminal settling velocity. It is the overflow velocity. And terminal settling velocity does not vary with the depth. So that's why depth is not important. I hope it is clear. Now we'll okay. So now we'll move on to our next problem. So the below data are given for a 10-meter long channel type grid chamber. Now the length is given to you. Q is given as 0.75 meter cube per second. Wastewater depth in channel at peak flow is given as 0.8 meter. Channel width is given as, or B is given as 3 meters. Specific gravity of inorganic particles is given as 2.5. G, that is your gravitational acceleration constant, is given as 9.8 meter per second square. Mu is the viscosity, that is given as 10 to the minus 3 Newton second per meter square at 20 degrees centigrade. And rho water, that is your density of water, is given as 1 gram per cc or 1000 kg per meter cube. The problem statement is, assuming Stokes law applies, calculate the maximum diameter, that is millimeter, of the particle that can effectively be removed with 100% efficiency. What is the time? Okay, so this is the last problem of today. What about the other data? So this, you are talking about the last problem, Puritra. Okay, we will see. What about the other data? What other data was there? Other data, all other data are not recorded. So that's why it was told as useful data given. Other data are not useful. So what is that? This data you had to utilize. These data you had to utilize. With data you had to utilize. Only depth was not important. So any other data is there? No other data is there. So what are you talking about? I didn't understand. In the last, no, this problem only. Right. So what are you? I please unmute yourself and tell what are you talking about. I didn't understand. Otherwise, we will solve the last problem of today's session. So only the depth data is excess here. And in the next problem also, I will give you a hint. So in the next problem, it is also a channel type grid chamber settling. Settling is what is occurring here. So that's why here also the wastewater depth, I don't think it will be necessary because velocity doesn't vary with depth. The concept of terminal settling velocity. The formula that I told for drag force, Ft equals to 6 pi eta RV. It 6 pi, sorry, yes, 3 pi mu dV. That will be used for deriving the formula. The maximum diameter. So to get the diameter, you require a formula, and to derive that formula, you require the concept of drag force. It is basically a force balance. The drag force plus buoyancy equals to the weight of the particle, or the apparent weight of the particle, that is weight minus buoyancy, equals to the drag force. In the drag force, the term terminal settling velocity will be there. You just have to equate it with the particle's weight and buoyancy that is being acted on the particle to get the formula. So I will just tell the formula in today's session. If you don't understand the formula, you just go whatever I told, the balance I told you already. So you just go with the balance in your home. It is your homework. You see whether you are able to derive the formula or not. Whether you be able or not, I will anyways be discussing the derivation in the next class. So today's class I will be just utilizing the formula. Okay. So again, useful data given here for the same type of settling scenario is L is given, the length of the tank is given as 10 meter. The Q flow rate is given as 0.75 meter cube per second. So in earlier problem it was 720 meter per day, I think. The breadth, that is perpendicular direction to your screen is 3 meter. So the solution will be something like this. And you can again see the height, that is h, which was given 0.8 meter or something. That was not important. That is not important in this case. So again, the surface area is important, and the settling velocity will be given something like this. So Vs, the terminal settling velocity, will be your flow rate, that is 0.75 meter cube per second divided by meter square, that gives you 0.025 meter per second. Okay, so BL is the surface area, which is your what is 3 into 10, that means 30. So 0.75 divided by 30, that means 0.25 by 10. So 0.025 by 0.025 meter per second, it is your terminal settling velocity. So terminal settling velocity is not asked in the problem. So the concept of drag force is required because they are asking the maximum diameter of the particle that can be settled with this velocity. That will be settling with this velocity. So that particles, those particles that will come in the feed water, they will settle with this velocity at the bottom of the tank. So they will travel this height with this velocity. Okay, from the top to the bottom of the tank. Now, as you have got this, now B and L, these two are not required after this. So I will explain actually this formula in the next class. So now just remember this. So this is coming from the force balance I told you earlier. FD, that is drag force, equals to apparent weight of the particle of diameter d. Apparent weight means weight minus buoyancy. Buoyant force applied on the particle by the water, by the displaced water, by the same volume of displaced water. What is buoyancy? Buoyancy is the weight of the liquid that has been displaced. Weight of the liquid has been this. So displacement water volume is equals to the volume of the particle. So if the particle is spherical in nature, so 4/3 pi r cube will be its volume. So I will actually derive this formula in my next class. So if you know this formula, if you have done SAT's regular lectures, if you have listened, then you will be able to understand. So I just have to put the values here. Vs is given as we just calculated the value of Vs. Rho of water is given as 1000. G, that is the specific gravity, is given as 2.5 minus 1. G, it is gravitational acceleration, is given as 9.8. D you have to calculate, whole divided by 18 into mu. Mu is nothing but your viscosity, Newton meter per second something. It is the unit. So all are in SI units. You get the value, you take this entire thing in left hand side and you just take the root and you get the value of the maximum particle diameter as 0.175 millimeter. Hope if you know the formula, it will be easier for you to understand the problem. Otherwise, anyways, I will derive the formula. I just told you the force balance, right? You do it yourself. You just check whether you can derive this formula or not. Drag force plus buoyant force equals to weight. So weight, that is acting downwards, drag force by water, and buoyant force by water is acting upwards. These two forces are equal. They are balancing each other in case of spherical particle. This is what Stokes' law says. So you just balance this and just derive the formula. Try to derive. Let's see whether you are able to do that or not. Otherwise, I'll solve it. Now next class. So hope if you just leave the formula, you are able to understand the other parts, right? अगर बाकी पार्ट्स में कोई डाउट है तो पूछ सकते हैं, नहीं तो आज का सेशन इधर ही खत्म. थैंक यू एवरीवन. So okay, so You don't have any doubt? We'll again meet in our next class. Good night. I will end the session within a minute. Bye bye. Hmm.